So here we are with chapter 15. We're going to be talking about solving radical equations. And the first comment that's made in the chapter sort of involves basic exponential equations. And they're just wanting to point out that, for instance, square and square root are opposite operations. Okay, and cube and cube root are opposite operations, and that's the basic strategy for solving radical equations. So for instance, if we were to have x squared equals 4, then the way we would solve for x is to do the opposite operation. Here x squared is being squared, so we would take the square root. And what we do to one side of the equation, we have to do to the other. And in this case, we would say x equals a plus or minus 2. Okay, and so there's sort of an extra step. If you'll remember in the previous chapter, we said that square root of 4 is plus 2. This refers to the principal square root. So there's an additional step here that we need to throw in, and that is to put a plus or minus in front of this square root symbol whenever we take the square root of each side. Got to put that plus or minus there. Now this doesn't apply whenever we run into equations of the type x cubed equals, for instance, 8. Alright, here our x is being cubed. We do the opposite operation. We take the cube root to just get the x by itself. Therefore, we have to do the same thing to the right side of the equation and take the cube root. And here, we simply have x equals 2. Okay, so that's pretty much what it's saying. To undo the square, we take the square root. To undo the cube, we take the cube root. To undo a fourth root, or something raised to the fourth power, we take the fourth root. Alright. Okay. And one of the things that we're going to be doing to solve our equation is we're going to have to FOIL certain things in our equation so that we can get the radical expression, such as the x squared, or the square root of x here. You can see that it's inside a set of parentheses. Okay, and to handle that appropriately, we have to get it outside, and before we do that, we've got this square sitting outside the parentheses. So we can't just square the square root part, we have to square the entire polynomial inside the parentheses. Alright, and this is a common place for students to make a mistake, but on the next page we're going to practice FOILing some expressions with radicals in them. Okay, so example 1, if you wanted to, we could write this out as a 2 plus 5 square root of x, and then another 2 plus 5 square root of x. Alright, and to apply the FOIL method, we would take the first term of the first binomial, and multiply it times the entire second binomial. Likewise, we take the last term and multiply it by the two terms in this second binomial. So this is the FOIL method. What we get here is a 2 squared, a 2 times plus a 2 times 5 square root of x. Okay, so that takes care of these two products. Now we multiply the 5 square root of x times 2, and if we reorder that, we see that we get 2 of the same terms, a 2 5 square root of x, and then another one, and then finally we multiply the last terms of each binomial, and we get a 5 times a 5, which gives us a plus 25, and then a square root of x squared. Okay, now if we go back through and we clean this up a little bit, we will have a 4 from the 2 squared. We will have a 10 square root of x, and then another 10 square root of x. And then this will simplify to be a 25x. If we square a square root, then this radical and that 2 knock each other out. They're opposite operations. So we just get a 25x. And finally, we can combine these two like terms in the middle to get a 20 square root of x plus a 25x. So now we've sort of separated our square root of x term away from the parentheses. Alright, so we just want to repeat that same process with example 2 and 3. One thing that we could do, just to try to speed us up, we could always write out two of these binomials side by side, or we could just say, take the first term, which includes all of this, and square it. We're going to have a middle term, and then we are going to have a third term. So the square of a binomial, in this case, is going to work out to be a trinomial. Now, the first term of the trinomial is the first term of the binomial squared. The last term, okay, right here, is going to be the second term squared. So we have a negative 3 squared. Alright. And then this middle term is going to be 2 times, double, the product of the two terms of the binomial. So this would be a negative 3 times a 4, and then we have the square root of x minus 1. Okay. So this sort of speeds us up. If this is confusing to you, then you can just simply do what we did with example 1. Now to square this first term, to simplify it, we get a 16, and then we have an x minus 1. The middle term would be a 2 times a negative 12 times a square root of x minus 1. And then the last term would be a 9. Okay, this first one, we want to get rid of these parentheses, separate everything out into individual terms. So we'd have a 16x minus a 16. Here in the middle, this middle term, we'd have a negative 24 square root of x minus 1, and then a plus 9 on the end. And you see that we can combine this minus 16 and the 9 to get a, let's see, well, we just have a 16x, and then we'll write our middle term, minus 24 square root of x minus 1, and then the minus 16 and 9 combined to give us a minus 7. So we have our x term, we have our square root term, and then we have our constant term with no variable. Okay, in this case, I'll stick with working with the trinomial. So I'll just write out 3 places for our trinomial, the 3 terms. The first term is going to be the first square root in the binomial, first term inside the parentheses, and I'm going to square it. The third term is going to be, I'll put a minus with this. It's going to be our minus square root of x minus 3 squared. Alright, and then the middle term is going to be double the product of square root x plus 2 times negative square root x minus 3. So this is going to turn out to be negative, so I'll put the minus here, and then I have my 2 square roots plus 2 and x minus 3. Alright, now for the first and the last term, we have a square and a square root. So they knock each other out, and we can just take the middle, the inside of the square root, and write it out. X plus 2. This middle term, it's negative, so I'll write this as a minus 2, and then I'll just put my 2 square roots. To the side. Finally, our third term is a negative squared and a square root squared. So the negative is going to drop out, and this radical is going to drop out to leave us with the x minus 3. So I have an x and an x, which gives me a 2x. I have a 2 and a negative 3, which gives me a minus 1 that I'll put right here on the end. Try to stick with some order for our terms. And then this middle term I will write as a negative 2, and I'll put these two expressions, x plus 2 and x minus 3, under the same square root symbol because they're both square roots and they're multiplied. So we can write this as 1 square root instead of 2. Maybe it looks a little less intimidating. And we could leave it like this. This is pretty much as far as we can go with this trinomial. So you have to know how to foil a binomial that contains a radical expression. Okay, here you see an example of a radical equation worked out. There is no binomial. Okay, this is our original equation that they want us to solve. There's no binomial squared here, so we don't have to apply what we did in example 1, 2, and 3 from above. But what we do have to do is isolate this radical part to one side of the equation. And so what you see here is this 2 was moved over to the right, and so 3 minus the 2 becomes a 1. And now the only term on the left hand side of the equation is the radical part, and it's a cube root. And so you can see here that now at this point both sides of the equation are cubed. Alright, this cube knocks out the cube root here. It knocks out this radical, and we're just left with the radicand, 2x plus 3. 1 cubed on the right just becomes a 1, and then here we are with just a two-step equation that we've seen since intro algebra. We get the x by itself at this point. We subtract 3 from both sides, and then we divide by 2, and here is our answer. And as always, you can take your supposed answer and plug it back into the original equation and double check it. Once it checks out, we can say that it is our solution to the equation, x equals negative 1. So this is the simple first type of radical equation that we're going to learn how to solve. And the basic idea is to get the radical part by itself. So here we have square root 2x plus 3 minus 1 equals 2. So I just copied it down. And now we have the radical part and then a minus 1. Our first step would be to add 1 to each side to isolate the square root. So on the next line, we now have square root of 2x plus 3 equals 3. And to get this x, to break it out of the radical, we first have to get rid of the radical. we have to cube it. Well, I'm sorry, not cube. Thinking of the last example, we have to square it because we're dealing with the square root. And if we square the left-hand side of the equation, we also have to square the right-hand side. Now, we actually square this number on the right, it becomes a 9. Over here, though, this radical and the square outside the parentheses, this and this just cancel each other out. Okay, and we're left with what's inside the radical. So on the left of the equation, we now only have a 2x plus 3. That was the whole purpose of squaring both sides of the equation, to get rid of the radical. At this point, we just have a two-step equation where we subtract 3 from both sides. We get 2x equals 6. We divide by 2. 2's cancel, and we get x equals 3. Okay, we can go back to the top to our original equation and double check our number. We have a square root of 2 times 3 plus 3 minus 1 equals 2. So we won't swap things back and forth from one side of the equation to the other. The right side is already worked out for us, so to speak. It's a 2. So as long as we compute this left-hand side, we just want to compare whatever that number is to the right. So we have a square root of 6 plus 3. 6 plus 3 is a 9. And the square root of 9 is a 3. And if we take 3 and subtract 1, we do get a 2. So our solution of x equals 3 works out. Okay, example 5, we now have a cube root. First step is to get the radical part by itself. Subtract 1 from both sides. That puts our radical by itself on the left and gives us a 2 on the right. And we now have to cube the left and the right. The cube and the cube root knock each other out, and we're left with the 3x plus 2 on the left. 2 cubed is an 8 on the right. And at this point, we just focus on getting the x by itself. So we subtract 2 from both sides. We get a 3x equals 6. And finally, we divide both sides by 3 to get an x equals 2. Okay, on the next page, you see we now have sort of a slightly different equation where there's not only an x term under the radical, there is an x term outside the radical as well. And so here you have the workbook has still used the same strategy that we used in the previous examples. We've taken the x and we've moved it to the other side. We're still trying to get this radical part by itself. Once we do, we simply do the opposite of the radical. In this case, it's a square root radical, and so we square both sides. And the only real difference is that now, instead of just simply having a number on the right-hand side, we also have this x term, and so we have to FOIL the right-hand side. And at this point, we end up with a quadratic equation. Alright? And so since it's quadratic, we have two solutions that we have to check. One of them checks out, but the other one, if you plug in x equals 6, you can see that plugging it into the original equation does not check out. Okay, so in the end, we say x equals 1 is our solution and x equals 6 is extraneous. Okay, so at this point it is pretty important with these types of equations to check your solution. So with example 6, we still want to get the radical by itself. So in this case, we have to add 1 to both sides first. We get the square root by itself, and we have an x minus 2 on the right. Now, we want to get rid of the radical, and it's by itself, so we are allowed to do that at this point. To get rid of a square root, we square it. What we do to one side of the equation, we have to do to the other, so x minus 2 gets squared, and so we're squaring a binomial now on the right side of the equation. We get an x, the radical and the square just knock each other out, and we're left with the inside of the radical, the radicand. And over here on the right, we end up with an x squared minus a 4x plus 4. And at this point, we have to revert back to what we learned from a previous chapter when we were dealing with quadratic equations. We want, since we have this squared term here, we want to move everything to one side. So we subtract this x from each side. We put it in standard form, having a 0 on one side and all of the other terms on the other is what we mean by standard form. And now we have to factor. We have two binomials. First term of each one is an x, and then we can write our m and n as minus 4 and minus 1. The x minus 4 factor is going to give us an answer, a result of x equals 4, and the x minus 1 will give us x equals 1. Alright, we'll check both of these, and we want to see if one of these, or maybe both, are extraneous, or they could both be a full solution. So we plug 4, okay, we are checking x equals 4. We plug 4 under the radical on the left, and then on the right we replace the x with the 4. Square root of 4 is 2. If we subtract 1, we get 1 on the left, and over here on the right, 4 minus 3 is a 1, and so x equals 4 is not extraneous. It's a full solution to our equation. Now we'll check x equals 1. We get the square root of 1 minus 1, and over on the right we have 1 minus 3. The right side becomes a negative 2, and square root of 1 is 1 on the left, and we get 0 equals to 2, and this is not true. So we would have to label x equal 1 as extraneous solution. Example 7, we have our radical part, and again we want to get that by itself as our first priority for solving this equation. We have to add x to both sides, so minus x plus x, those cancel. 3 plus x is just an x plus 3 for the right side of the equation. On the left we have the square root of x plus 3, and the radical is now by itself. We've isolated the radical, so we do the opposite for a square root, and we square both sides of the equation. This knocks out the square root. We FOIL the right hand side. We get an x squared plus 6x plus 9. And we have a squared term, so we have to fall back on getting the equation in standard form. So this x plus 3, I'm going to move it to the right, and to do that I have to write below each side minus x and minus 3. That leaves us with a 0 on the left, 4x, 5x, a 5x, and a 6. At this point we factor. And my numbers let's see, are going to be 2 and 3 positive. Okay. These factors are going to give us answers of -2, and the factor of x plus 3 will give us, once we set it equal to 0, will just simply give us an x result of -3. Alright, to check these we go back to the original, and we'll check -2 first. We replace the x in the radical with a -2. And on the left hand side we also have minus x, so we'll write minus a -2. So we want the left hand side to work out to be a 3. Alright. In the radical we end up with a 1. On the outside of the radical we have -2, which is a plus. Square root of 1 is 1, and 1 plus 2 does equal 3. So x equal -2 checks out as a full solution. And so we check our other one. So I'll just write check x equal -3 here. Inside the radical that becomes a -3 plus a 3. Outside of the radical, replacing the x with the -3, we have a -3 situation. And so here we go. Inside the radical we get a square root of 0. Outside we have a plus 3. Square root of 0 is 0, so this just cancels out. And 3 equals 3. So both of our solutions check out this time. We do not have an extraneous solution. Okay. Our final type of equation we're going to deal with is one where we have several radicals. Okay, but they're going to be the same type of radical. So you can see the solution that's worked out for us. This example here in the workbook has 2 square roots. Okay, and the strategy is isolate one radical. Okay, you can see they got the square root of x minus 1 here by itself. Then they square it, and so the right hand side over here turns out to require quite a bit of work. Okay, this is why we squared those binomials at the beginning of the chapter. This is where that comes into play. So we square this. The left hand side radical, it was by itself, so when you square it, that radical disappears. But when we square the binomial on the right, we're left with one radical. And so at this point, that radical, we isolate the remaining radical. Okay, so once we get to this point, we are basically dealing with the equations from the previous examples. One radical, get it by itself, square it, and then solve for x. Alright, so this basically boils down to either having to square or cube the equation twice instead of just once. Okay, so example 8, I will keep the square root of x plus 8 on the left side, and I'll write below it plus square root of x minus 4. I'm moving this radical to the right side, so I'll write that underneath the right as well. So minus and a plus, these radicals cancel. This square root is now by itself on the left of the equation. The other radical has moved and changed signs to the right side. And at this point, we note that we're dealing with square roots, and we square both sides of the equation. Alright, the right hand side is the square of a binomial, so we have 2 squared, which is 4. We have double the cross term, so this 2 is just from doubling. We'll write another 2 for this first term, and then we'll write down the second term right beside it. So what we have here is just the product of the 2 terms and then an extra factor of 2. And for our last term, we write square root of x minus 4 squared. Simplifying this gives us x plus 8, nothing changes on the left, a 4, plus a 4 times the square root of x minus 4, and then this just becomes an x minus 4. The square cancels out this square root here. Alright, so you see now that we have 1 radical left. We started with 2, now we just have 1. We want to get this piece by itself. Alright, to do that, we subtract 4 from both sides. We can move this x along with it, and let's see, these x's cancel on the left, and we get 4 equals 4 times the radical, and these x's cancel, and you see I still have a minus 4 on the right. We need to move it like we did the other 4, so we'll add 4 again to both sides, and this gives us the equation 8 equals 4 square root of x minus 4. The radical is not completely by itself at this point. We want to get rid of this 4 in front of it, and so we divide by 4 on both sides. Because the 4 was multiplying, it's just sitting right beside the radical, no plus or minus sign in between. So it's multiplying the radical, we divide by 4, and we end up with a 2 equals the square root of x minus 4. Alright, so quite a bit of work. Most of the work is involved with this part here, squaring the binomial that you end up with. Alright, so I'm going to make a little bit of room so I can continue working this out. Take this back to the top. And the last little stretch of this equation just involves squaring both sides. 2 squared on the left is a 4. Square and the square root cancel on the right. We end up with a 4 equals a x minus 4. We get the x by itself, add 4 to both sides, and we get x equals 8. Okay, so at this point we'll just go off to the side and check our solution. Check. Square root of 8 plus 8 minus square root of 8 minus 4, does that equal 2? Question mark. Here we have the square root of 16. The other radical is the square root of 4. Square root of 16 is 4. Square root of 4 is 2. And 4 minus 2 is a 2, which equals the right hand side. So our solution checks out. X equals 8 is not extraneous. Example 9, we want to move one of the radicals to the opposite side. So when it moves, it's going to change signs and become a minus 2x plus 5, the square root. We have one of the radicals by itself. It's a square root, so we square it. We go to the right and square everything over there. It becomes a binomial squared. The radical on the left gets knocked out. Okay, we full the binomial squared and we get a 1 squared, which is just a 1. We get a negative because we have this negative in the middle term. 2 automatically for squaring a binomial, times the first term and then times the second term. And we've already accounted for the negative of the second term here. Alright. The last term of the trinomial is going to be a negative square root of 2x plus 5 squared. Okay, square the second term of the binomial. Cleaning this up, we have a 1. We have a minus 2 square root of 2x plus 5. And then here we square a negative and a square root, so we're left with just a 2x plus 5, the inside of the radican, or I'm sorry, the radical. And here we have one radical left. We started with 1, 2, and we just have 1 left. So now we want to get this one by itself. We could combine like terms on the right. We have a 1, we have a 5. Becomes a 6. Alright. So to get everything moved away from the radical, the first thing we should do is subtract the 2x from both sides. That takes care of the 2x. We move the 6 away from it. So we subtract 6 from both sides. On the left, that becomes a minus x and a minus 4. Alright, and since we have this x term over here, we're not going to divide by a negative 2. That would give us a radical or a rational expression. And it would probably be easier just to simply square the two sides at this point. This negative 2 isn't going to cause us any problems. We'll just have to square the negative 2 on the right to get a 4. And then when we square the radical part, we simply get a 2x plus 5 that multiplies the 4. Over here on the left, we end up with an x squared. Then we're going to get a plus 8x and a plus 16. Alright, so at this point our radical is gone and we're trying to get x by itself, but we have this x squared term here, so we've got a quadratic equation. We'll distribute the 4 to get rid of the parentheses. And with our equation having an x squared term, we'll move everything to that side and put our equation in standard form. So that involves subtracting 8x and subtracting 20 from both sides. On the left, we get an x squared. The 8x is canceled, and we get a minus 4. And we have a 0 on the right. To factor this, there's actually a couple different ways we could go here. To factor this, we'd get an x plus 2 and an x minus 2. And the x plus 2 is going to give us a solution of x equal negative 2, and the minus 2 factor is going to give us a solution of x equals positive 2. Making a little room to go back and check each of these solutions. We get negative 2 plus 2 if we're checking x equal negative 2. Negative 2 plus 2 underneath the first radical. The second radical is a 2 times the negative 2 plus 5. We want that to work out to be a 1. This first radical cancels because it's just simply the square root of 0. The second radical becomes a negative 4 plus a 5 underneath the radical. And a minus 4 and a 5 is a 1. So here we have the square root of 1 equals 1, and our solution of x equal negative 2 checks out. It is not extraneous. To check our solution of plus 2, we go back to the original equation, plug a 2 in for each of the x's, and we want this left hand side to work out to be a 1, matching the right hand side. The first radical is the square root of 4. The second one is the square root of 9. 2 times 2 is 4 plus 5 is 9. We get a 2 and we get a 3, and that equals 5, which does not match the right hand side. So we label the solution of x plus 2 as being extraneous. Okay, two more examples to wrap up this chapter. Here in this equation we have two radicals and their cube roots in this case. This one works out to be a little easier than the last two because we have two radicals and we do not have a third term. We just simply have a 0 over on the right. We'll follow the same procedure and move one of the radicals to the opposite side of the equation, just like this. So 0 minus cube root of x plus 5 just leaves us with cube root of x plus 5 on the right, okay, with the minus sign. Cancels on the left side. That was the point. We just wanted to move one to the right hand side, and on the left we only have one radical, 2 times the cube root of x minus 4. So we have a single radical on the left and a single radical on the right. We'll cube them because they are both cube roots. Okay, we actually have to apply the cube to the 2. It sits outside the radical, so this is 2 cubed, which is an 8, And here for the radical and the cube, they just cancel one another out. So from the radical, we're just left with x minus 4. A negative cubed on the right is a minus, so we didn't get rid of the minus, it's still there. But the cube root and the cube drop out, and we're left with the x plus 5. So at this point, we want to get rid of the parentheses. So we distribute. We get an 8x minus 32 on the left, a minus x minus 5 on the right. We'll isolate our x variable, add x to both sides, and then I'll move the minus 32 by adding it. I'll move it to the opposite side away from the x. So these cancel, minus and plus x cancel. We're left with a 9x equals a 27, negative 5 plus 32. Divide both sides by 9. We get x equals 3. Is our solution extraneous? Plug it into the original equation. Okay. Replace the x with a 3. First radical becomes a cube root of a negative 1. Second radical becomes the cube root of an 8. This becomes cube root of negative 1 is a negative 1, so negative 1 times 2. And then the cube root of 8 is a 2. So our situation is a negative 2 plus a 2, and that does equal the right hand side, which was originally 0. So our solution checks out. It's not extraneous. Alright, our final equation, we ended up getting one where every term is a radical. Not really a big deal. What we're going to do here is we're just going to start out squaring both sides. Okay, at least one of them is by itself. We don't have to move one radical to the other because we'd still have one side with one radical and the other side with 2. Either way we go. So we're not going to do any extra work here. We're just going to start out squaring both sides because we do have all square roots. The left is a binomial, so it's going to be a trinomial once we expand it. On the right hand side, this is just a single radical, and if we square it, it knocks out the square root. So the right side is simple. It just becomes a 4x plus 5. A little bit of work required on the left. We square the first term, we square the last term to get the first and third term, and now the middle term is just the product of the two radicals with an extra factor of 2. Okay. Now, the first and third term, they get rid of these two radicals. Knock the square cancels out the square root. So this first term becomes an x. The middle term we can write as a single square root. Not plus. This would be x times the other radicand, x plus 3. It's just I put them both under the same radical. Not much we can do there, but it makes it look nicer. The third term, square cancels out the square root, and we're left with x plus 3. Alright, we can combine like terms on the left. This x combines with that one, so we get a 2x then we have a 2 times the radical part, and then we have a 3. We move everything away from the radical. So we started with 3, we squared both sides, and now we're only down to 1. We move the 2x and the 3 away from the radical, so we have to subtract them from both sides. On the left, we're left with a 2 times the square root of x times x plus 3. On the right, we have a 2x plus 2. And if you'll notice, this 2 is multiplying the radical, and we kind of want to divide. If you look at the right-hand side, you can see that there's a 2 in each term. So this 2 will cancel out completely. Dividing by 2 will not leave us with a fraction here, so I'll just go ahead and divide. Here we just simply have the radical part, x plus 1. Try to make that look a little neater. So here we are with radicals isolated. Everything's moved to the opposite side. It's a square root. And so all we have left to do at this point is square both sides. It becomes an x times an x plus 3 equals an x squared plus 2x plus 1. Okay, I had to fold the right hand side. Alright, need some more room, so I'll take our current equation back to the top. The left hand side, I could distribute this x and get rid of parentheses, and that would give us an x squared plus a 3x. And now you see we have squared terms, x squared. So what we want to do is put it in standard form, move all of the terms to one side. And so you see when we try to combine the x squareds from opposite sides of the equation, the squared term just ends up canceling out. So with the x squared canceling out, we're no longer trying to get it into standard form. At this point, we can just get the x by itself, and that amounts to subtracting 2x from both sides to get an x on the left. 2x's cancel on the right, and we were closer to our answer than we thought. We get an x equals 1. We'll go and plug it into the original equation, check x equal 1. We get a square root of 1. We get a 1 plus 3 in the second radical, and the right hand side of the equation becomes a 4 times a 1 plus a 5. Square root of 1 is 1. 1 plus 3 is 4, and the square root of 4 is 2. We have a square root of 9 on the right, 1 plus 3 on the left, or I'm sorry, 1 plus 2 is 3 on the left, and the two sides end up being equal. 3 is equal to the square root of 9. So x equals 1 checks out. It is not extraneous, but it is our only solution to equation of example 11. That was our last example in the workbook. Thanks for watching.